All right, for number 11, it's talking about applications where derivatives are involved. A lot of times, I'm not going to directly tell you find the derivative when giving you a word problem. Instead, I'm going to use language that indicates that a derivative is helpful. So we've already talked about some of those items. Okay, the most common thing related to a derivative is slope or rate of change. So seeing those items is going to really indicate that this is a derivative problem. Okay, but other things that I want to point out are related to these specific word problems that I've picked out here. Okay, so this first one, it's talking about this profit function. If you specifically see that function notation, we definitely know a derivative is involved. Okay, as relating to the other two problems, I'm going to kind of just skip ahead here. When you see the word marginal, that's also telling you a derivative is involved. Sometimes it's marginal revenue and sometimes it's marginal cost, but either way it's the derivative because it's talking about the change in the revenue or the change in the cost. Okay? And then the last one related to it is velocity. Okay, velocity is also finding the first derivative because velocity is your rate of change. In this relationship, talking about a rock being thrown. So, let's look at this first problem. It's asking you for this function, talking about profit of selling books, what is P of 10 and what is the derivative at 10, and then explain in context. Okay, so the first thing to really emphasize here is this is the original function and you're just subbing it directly into both pieces, being careful for order of operations. So the first one is 5 times 10 is 50 minus 6. On the bottom, 2 times 10 is 20 plus 3. And then we're just having 44 over 23. And you throw that directly into your calculator. Oops, 44 over 33. And that gives you over 23. Like I didn't think that looked right. 44 over 23. And then that gives you the 1.91. Because it's talking about money that you're making from your books, it makes sense to round to 2 decimal places. Okay, so their profit off of 10 books is really not that much. It's just $1.91. Okay, then the next one, the derivative is talking about instead of just the books being sold, it's the rate of the profit at a certain value. Okay, so we'll find the number first and then we'll describe in context what it means. So in order to sub in 10 to the derivative, you need to know the derivative first. Okay, so we've got to use our quotient rule here. So I like to do the derivative of the first part, so that's just 5, times the second part, minus, switch them around, derivative of the second part times the first part. And then all divided by the denominator squared. Again, you won't have to mess with expanding that very often. Okay, but we are going to simplify the top. Because these are just polynomials, we can distribute through and some like terms are going to show up. So we've got 10x plus 15. Second part is minus 10x. And then negative and a negative makes a plus 12. And the bottom just comes along here, 2x plus 3 getting squared. So here are our like terms. The 10x cancel, and we've got a 15 plus 12. That's 27 over this 2x plus 3 squared. That is our derivative formula. So now we can go ahead and substitute in the 10 and simplify. So that's 27 over 2 times 10 is 20 plus 3 is 23 squared. And again, you can type that directly in your calculator. 27 divided by 23 squared. And we've got this really decimally looking number, but again, it's money, so we're going to check out just to 2 decimal places. So that would be 0.05 or 5 cents. And we want to relate it to context. So again, we're talking about profit from selling books, but because it's the derivative, it's talking about the rate of change. Since this 0.05 was a positive number, our rate of change is positive or increasing. So it's saying you're going to make 5 cents more, that's our increase part, more on the next book than you are on this 10 itself. Okay, so this is always per 1 more than what you start with. Okay, just because when we're talking about a rate of change, it's over 1 always when we're thinking about it as a fraction. Okay, so that's where that 11th book is coming from. Next problem, we're going to talk about that marginal, okay, but again, when it says this Rx regular and asks you for the marginal, that's just related to the derivative. So we're going to find our derivative of Rx using our, here, just our power rule. This is going to be 20. And again, don't be fooled by this fraction. This is really 1 over 500 x squared. When the x is on the top, it's really the same as to the side. So we can use our same power rule. This is 2 over 500 is 1 over 250. X decreases by 1, so it's just the first power. So there's my derivative. And I want to find that when there are 100 tables. So we're substituting in 100. So this is just 20 minus 100 over 250, and you can throw that directly in your calculator as well. I'm going to do a little bit of reducing first. 20 minus 5 goes into both of those, and then I know it's 19 and 3/5, that's the 19.6. Again, you can put that in your calculator, that's fair game. Okay, but in context, it was talking about the revenue from selling tables, so this is money, but because it was directly related to the marginal revenue, or the derivative, it's the increase in revenue that's happening, okay? So here it's the 19.16 more dollars is happening for 100 table or for 101 tables than it was for that 100. Okay. This one, it says determine when the marginal revenue will equal 0. So it says literally take your marginal revenue, which we just found, and equal it to 0. So I'm going to go to the side here and take my 20 minus, this was 1 over 250, but I'm going to actually rewrite it the way they did, x over 250, just to make it a little easier here. And we're saying it equal to 0 because they said to. So we want to get this, just add it over. So we've got 20 equals x over 250. And the reason I put it over that instead of to the side is so we can really see we're going to multiply by 250 here. So then we've got our x equal to 250 times 2 is 5,000. And this is talking about when, so that's at what x value, our x was related to tables, so when 5,000 tables are sold, that's when our marginal revenue is equal 0. That's essentially when our profit is not increasing or decreasing. Last problem is dealing with velocity, but it says a rock is thrown into the air from the top of a building, and its height at the time t is given by this equation. I'm going to take a moment to talk about this equation. It's actually Newton's law, which looks like h of t equals -1/2 acceleration due to gravity t squared plus initial velocity t plus initial height. Okay, so when you're looking at this piece, the initial height, this 60, is telling you how high that building was that it was jumping off of. This number in front is actually a constant that you'll always see. It's the acceleration due to gravity based on gravity being a constant in on Earth, and that ratio is actually 32 feet per second squared. Okay, but when you simplify it, taking that -1/2, you get -16. Okay, so that's something that's always going to show up. I wanted to take a minute to talk about that this is a law that happens the same way every single time. Okay, so you're going to see things similar to this when relating to questions with velocity. But it says, after how many seconds, so that's solving for t, will the rock hit the ground? So when I say hit the ground, I mean the height is 0. And because I'm talking just about the height, then I can go in here and just set the height equal to 0. That looks like 0 equals -16 t squared plus 48t plus 60. This is something that we can solve by factoring, quadratic formula. Really, those are the methods that are most common. You could also do it with graphing if you had a appropriate window. Okay, what I'm going to do is talk about this with quadratic formula, but the first thing I'm going to do is notice that these are all even, and in fact notice that the number 4 goes into all of them. So I like to reduce this down by dividing out that 4, and I get rid of the negative just because I like my a positive. It technically doesn't matter. So this would be here a positive 4t squared. This would be a negative 12t, and this would be a negative 15, and that makes my equation look a little bit smaller, which means my calculations will be easier. Okay, but quadratic formula, opposite of b plus or minus b squared minus 4ac, all divided by 2a, will look like opposite of b is positive 12 plus or minus. Negative 12 squared is positive 144, minus 4 times the 4 times the negative 15. All divided by 2 times a is 2 times 4. And then we're just going to simplify this part. Honestly, I recommend throwing it into your calculator. Even if you can do it in your head, it's just easier when we're going to end up simplifying a bunch as well. So 4 times negative 15. And then we've got the square root of that number. So here's how this is going to work. We're going to type this whole thing in, just making sure we pay attention to order of operations. So the 12 plus the square root of this, we're going to hit enter after, before we divide it by 8. So my first answer is 3.95. Okay, but it's quadratic, which means there are really 2 answers. So now we're going to do that same thing, and we're going to change it to a minus. So this time I'm going to subtract. Again, hit enter, then divide it by the 8. Second answer, negative 0.95. But because it says after how many seconds, and we can't have negative seconds, we only have one answer there. Okay, again, graphing is another option for this, but choosing a window to make that show up might be more challenging than solving it using algebra here. The second parts are a lot faster because when I ask you about velocity, I mean the derivative. So once I take the derivative of this, it actually is no longer quadratic. Let's see it work. So h of t, looking for the derivative here, using our power rule, we've got negative 32t. And then plus 48, there it is. This first one says, what was the velocity of the rock when it was initially thrown? Initially thrown means the time is 0. So I'm just plugging in a 0 there. So this is 0 plus 48, or just 48. Velocity is feet per second, so 48 feet per second. Then it says, what was the velocity? So I'm still using the same function of the rock when it hit the ground. Well, I found when it hit the ground was 3.95, so I'm just plugging in that number I got. Okay, so going through here, I'm going to write negative 32 times that number I got, and I have it in my calculator, so I'm just going to pop up here and grab it. Okay, but you can use the rounded version, doesn't matter. And then we're going to do plus 48. And it tells us about negative 78.38. Okay, don't worry about what to round to on here because I'm going to tell you on my MATLAB what I want you to round to. But again, it's feet per second. When we're talking about rate of change, it's got to be something per something. That is it. If you do have any questions as it comes to these application and types of words that mean really find the derivative, please feel free to reach out.